Hello viewers, welcome to our class today. Today we are going to look at a special part of trigonometry. And that special part of trigonometry is special angles. To start with, we need to look at what sign of some angles are. For instance, angle 60, 0.8660254038 continues that way, and all the angles here, sine 60, which is 0.5, tan 60, and so on. Yes, it is very important to note that most of these angles have values that have no end. In other words, the numbers here continues without ending. Cos 30 continues without ending. Tangent of 30 degrees also continues without ending. However, if we approximate any of them, like assuming we are going to approximate sine 60 degrees, which is going to be 0.8660 to 4 significant figures, then we know that any approximated values here will no longer be the exact value. I know we need an exact value because exact values are very important in science and engineering when we are going to need to use only better value, not an approximated value. Sine 60, cos 60, all these trigonometric ratios of 60, 30, and 45 degrees are very important in mathematics and engineering. Because of that, we want all these values to be exact. Therefore, we are going to use special angle to make sure that they are exact value. They are called special angles because of the role they play in science and engineering. Let us consider the first one, cos 60 degrees and 30 degrees. Let us consider 60 degrees and 30 degrees. To get special angles of this, that is going to be in a short form that will not have an approximated value, we need a diagram with an equilateral triangle, which is going to have 2 units each. And so we get it as the 2. Of course, from here to here is 2. As you know, we call this triangle A, B, C. Then we have that BC is also going to be 2 units. But let us bisect this angle. Yes, if we bisect this angle and meet BC at 90 degrees, we can call this position midpoint M. What it means is that we now have AMB and AMC as right angle triangles there, which is going to give us, if this is the midpoint, this is 1 and this is 1 unit. Since BC is 2 and M is the midpoint, what it means is that we can easily get AM to be able to complete the third part of the right angle triangle, the third side of the right angle triangle. Let us do that immediately. Knowing very well that 60 is here, remember, a quadrilateral triangle has 60 degrees into 3 places. And when we have bisected this angle, we have here 30 degrees. And we have here 30 degrees. We are going to use only one part of this. That means we can produce another diagram that looks like this, where this is A, the right angle here, this is 2, and this is 1. Let us find what is going to be AM or AM in the small triangle there. imagine that this triangle is just part of triangle ABC. Now, how do we get this angle? From trigonometric ratio, that means Pythagoras theorem. We are going to find out that this is root 3. Remember, root 3 is coming from 2 squared, the hypotenuse squared, is being equal to, assuming we call this x, being equal to x squared minus 1 squared. If that is the truth, then we are going to have 2 squared minus 1 squared is equal to x squared. Yes, we're looking for the value of x. And so, what we have here is 4 minus 1 is equal to x squared. When we have it, it is going to be 3 is equal to x squared. Then, we find the square root of both sides. Square root of x squared is x, and square root of 3 is root 3. So root 3 is equal to x, which is exactly where we got that root x. And so, we know that this place is 30 as we show in the bigger triangle. And this is 30 degrees. And this is 60 degrees. Let us find the values of sine, cosine, and tangent of both 60 degrees and 30 degrees. That will come without any approximation. Because we can see that no one can make use of all these values, especially when they have no end, because they have not ended here. We continue without having an end. Therefore, since we don't want approximation, we don't want a value that is not exact, we can make use of the values we have here. Let us start with 60 degrees. 60 degrees. In 60 degrees, let's find the sine. Sine 60 degrees here is going to be opposite of hypotenuse. And that means this is 60 degrees. The opposite is root 3. Hypotenuse is 2. Which is going to give us root 3 over 2. This value will be used as sine 60 degrees instead of this value that has no end. You can see to that. So the real need for this is that we are now using a value that is that's exact, instead of using a value that must be approximated because of its nature. Alright, the next one is cosine 60 degrees. To get cosine 60 degrees, which is adjacent of hypotenuse, that means we are going to have it 1 over 2. Actually, 1 over 2 is something as 0.5, which is the number we have here. That one has an end, but others do not. And then we get to tangent here, tan 60 degrees. Tan of 60 degrees is going to be equal to opposite over adjacent. Opposite over adjacent. And opposite over adjacent here is root 3 over 1. Root 3 over 1 is exactly root 3. Which means tangent of 60 degrees, which has no end here, we are going to get the value to be only root 3 as the exact value. And so, that is how we can now use 60 degrees, find their ratios without approximation. Let us get to 30 degrees. Angle 30 degrees. In angle 30 degrees, we are interested in finding the sine, cosine, and tangent as well. We may leave cosecant, cotangent, and cosecant, simply because we know they are the reciprocal of the other ratios. So what do? Let's find sine 30 degrees. Sine 30 degrees will give us opposite over hypotenuse. Opposite over hypotenuse. That is going to give us 1 over 2 or 0.5. Actually, that one is the same here. There is no problem for that. It has an end, 0.5. But what of the cosine? What of the tangent? It's because of those ones that we must find a way to use them without approximation. So what do we get here? Cosine of 30 degrees now. Cosine of 30 degrees is going to give us cos, which is adjacent over hypotenuse. Adjacent of hypotenuse will be root 3 over 2. Finally, we talk about tangent, tan 30 degrees. At tan 30 degrees we have opposite over adjacent. That is opposite over adjacent, which is 1 over root 3. Or when you rationalize, which is multiplying both numerator and denominator by root 3, you have 3 root 3 over 3. Any of them, whether you write it as 1 over root 3 or root 3 over 3, they'll give you the same value. So that is for angles 60 degrees and 30 degrees. Let us complete that of 45 degrees. Angle 45 degrees. In getting angle 45 degrees, we need to have a different diagram that will produce the angle. Assuming we take it that this is a right angle triangle, which is also an isosceles triangle, where this is 45 degrees and this is 45 degrees. Then let us give 1 unit to this line and 1 unit to this, which means that using Pythagoras theorem, the hypotenuse is going to be root 2. Assuming you don't know how that root 2 comes, assuming we call it y squared is equal to 1 squared plus 1 squared. Remember, we have already at the initial time given 1 unit to these sides arbitrarily. So here we're going to have y squared being equal to 1 plus 1, y squared equal to 2, and y is equal to root 2. That's how the root 2 comes about. And then the next thing we're going to do is to come and find sine of 40 degrees, cosine of 40 degrees, and tangent of 40 degrees. 40 degrees as an angle. What is sine? Sine 40 degrees, from what we have here, sine 45 degrees will give us sine. Whether we are using this angle or this angle, they are just the same. They are the same, they produce the same result. Opposite over hypotenuse. We are using this angle now. Opposite over hypotenuse. And so we are going to take it to be opposite of hypotenuse. There will give you 1 over root 2. If you don't write it as 1 over root 2, you can write it as root 2 over 2, which we will get when you multiply both the numerator and denominator by root 2. That means rationalizing denominator. Also, cosine of 45 degrees. Cosine of 45 degrees. The cosine of 45 degrees now will also be adjacent of hypotenuse, which is 1 over root 2, which will give us the same root 2 over 2. Remember, whether it is this or that, they will give you the same value. Tangents, tan 45 degrees. Tan 45 degrees here will give us opposite of adjacent, which is 1 over 1. But remember that 1 over 1 means 1. So, by so doing, we can get the trigonometric ratios of 60, 30 degrees, and 45 degrees without any approximation. We get them in its raw or its natural stage. I hope you understand. So any day, in any calculation, in physics, in any other course in engineering, that you wish to avoid approximation, we are expected to use the special angles that will give us the exact value. Remember, in Hidden Treasure Educational Consultancy Service, we encourage people to be numerate. If you are literate alone, you cannot finish up what you need to do as a person in this 21st century. So as you are literate, we expect also nature, environment, our new society also expect that you'll be numerate at the same time. Thank you for now, and see you in another classes we are going to have.